In this last video for our matter unit, we are going to talk about 4 basic types of chemical reactions. We are going to talk about synthesis reactions. In a synthesis reaction, you combine chemicals together to make one product. Decomposition. In decomposition, you start with one reactant and that breaks down into similar pieces. Single replacement, where one substance switches spots with another, and then double replacement, where we will see 2 switches occur. Now, these 4 types of reactions will cover a lot of the reactions that we do throughout the year, but obviously there are some other ones that we will talk about throughout the year, but again, these 4 will make up a large percentage of the reactions that we will see throughout the year. In a synthesis reaction, the substances will combine together. So you are always going to start with 2 or more reactants, and they will join together to produce one product. So in our 2 examples here, we have our simple example, A plus B joins together to make AB. Or we have hydrogen gas plus oxygen gas joins all together to make water. So we're always producing one product. So synthesis, join together to make one product. In a decomposition reaction, it is going to be the opposite of a synthesis reaction. So in a decomposition, we will start with one reactant, and that one reactant will break down into simpler pieces. So, for example, compound AB breaks apart into single A and single B. So, one reactant, AB, breaks apart into simpler pieces. Or water breaks apart into hydrogen gas and oxygen gas. In a single replacement reaction, one substance will switch spots with a different substance. So if we take a look at this first example here, we have A plus BC makes B plus AC. So in this one, A and B switched spots. So you have one switch, hence single replacement. Now, a single replacement reaction will always follow this general format. Element, so that would have been A, plus compound, so that would be BC, makes a new element. So now we have B by itself and a new compound. So element plus compound makes new element, new compound. So in this second example here, we have copper, that would be our element, plus AgNO3, that would be our compound. Then we have Ag by itself, so that's our new element. And then copper nitrate, the CuNO3 would be the new compound. So the copper and the silver switched spots. So we have one switch, single replacement. Another way to look for a single replacement is you always have something that will be single on each side. So copper single, it's by itself. Then silver is single, it's by itself. In a double replacement reaction, you will be able to see 2 switches. So we will have an exchange of ions. And a good way to look at it is that everybody gets a new partner. So if we look down at this first example, A and B were together. C and D were together. Now A is combined with D and C is combined with B. So that's what I mean by everybody gets a new partner. The general formula for a double replacement reaction is going to be compound plus compound makes new compound, new compound. So everyone will always be doubled up. There will not be anybody single on either side. So we have AgNO3. that's a compound. NaCl, that's a compound. Makes a new compound, AgCl, and another new compound, NaNO3. So that is another good way to look at it. Or the everybody got a new partner. So Ag was partnered with NO3. Now it's partnered with Cl. Na was with Cl. Now it's with NaNO3. So what we need to be able to do is we need to be able to look at a reaction and know what one of these 4 types of reactions. So we should be able to look at a reaction and know whether or not it's a synthesis, a decomposition, a single replacement, or a double replacement. Again, this will not cover every single type of reaction that we do throughout the year, but it will cover a large percentage of those.